Welcome guys, in this video we are going to see how can we deploy YOLOV5 with OpenCV. In the previous video, we used the YOLOV5 model with PyTorch Hub and we saw that the method was dependent on a number of packages and modules. But in this method which we will see, we have an advantage that there are only two dependencies which are OpenCV and NumPy. So now let's get started. First of all, we will go to the YOLOV5 repository, and if we scroll down, we will find a number of pre-trained models available. Actually, there are 5 models of different sizes and each model has 2 versions. The first version is trained on the images having the size of 640 pixels and the second version is trained on the images having the size of 1280 pixels. So in this way, there are total 10 pre-trained models available at the time of recording this video. We have to select any one of them for now. So I am going to use this YOLOV5 Nano model. I will just click on it and it will be downloaded in my system. And once it is downloaded, then we will move it to our project directory. After it, we will come to the code editor. Now, the problem is YOLOV5 is developed with PyTorch framework and it is available in .pt format, which is actually not supported by OpenCV. So what we will do is we will convert it into ONNX format and then we will be able to use it with OpenCV. In order to do this, we will clone the YOLOV5 repository. We will click on code and from here you can download the zip file, or if you have Git installed, then just copy this link and then we will go to the code editor. And in the terminal, we will write git clone and then we will paste the link and just press enter and this will clone the repository. Now the repository has been cloned and this should be somewhere in the project directory. Now here you can see a folder YOLOV5 which is basically the clone repository. Inside it there is a file requirement.txt. Just open it and it has the name of all the required packages which we need for conversion. Now here we will make some slight changes. Firstly, in the line number 12, we will explicitly set the torch version to 1.11. The reason we have to do this because at the time of recording this video, there is an issue with the latest version of torch, and if we use that, then the conversion will not occur properly. Now the second thing we will do is we will also set the OpenCV version. Now this one is just the recommendation and not necessary. I did this because for the latest version of OpenCV, the autocomplete feature is not working. So we can go with any older version. Now after this we will save the changes and then we will copy the path of this file. Then in the terminal, we are going to write pip install -r and then we will give the path to this file. And then press enter and this will install all the required packages. Just to save the time, I have already installed these packages, but for you they are going to be installed if you are doing this first time. So it will take some time. Now once the installation is done, then we can convert the YOLO model into ONNX format. And for this, in the repository, there is a file named as export.py. We are going to use this file for this conversion. So what I will do is I will copy this file path and then in the terminal we are going to write python, then we will give the path to this file and then we will write --weights and then we will give the path to the YOLOV5 model which is in PT format. So just copy its path and provide it here and then we will write --include ONNX. Now on entering this command, this will convert the model in ONNX format. Okay, now the conversion is done and there should be a new file. Here it is. Now we can use this YOLOV5 model with OpenCV. So let's start writing the code. First of all, we will import OpenCV module, and then we need NumPy module. And then we need a video file on which we will run the inference. So for that, let me show you. This is the video file I have. Now to load it, I will write cap equals to cv2.video capture, and inside it I will give the name of my video file. And then to access the frame of this video, I will use a while loop. And inside this while loop, I will write img equals to cap.read. And then in the bracket, I will write 1. Now I will check whether I get the frame or not. So I will use an if statement, and if the image is none, this means we do not get the frame, so we will simply break the loop. Otherwise, if we get the frame, then we can display it on the screen. So I will use imshow function of OpenCV, and inside it I will give the name to window and then the image. After this we will give some waiting time, and for now waiting time will be 10 milliseconds. And in case if we have to close the video anytime, so for this I will store the return value of wait key function, and then using if statement I will check which key is pressed. So in case if the Q is pressed, it means we want to close the video, so we will simply break the loop. Now let's run the code and see if this is working. Okay, this is working, but the frames are too big, so we need to resize them. So here I will write img equals to, and then I will use resize function from OpenCV, and this will take two arguments. First one is the image, and the second argument is the size which I want. Now let's run the code again. Okay, the frame has been resized. Now the next step is to run the inference on it using YOLOV5 model, and for that we need to load the model. So here I will write net equals to cv2.dnn, and inside this module we have a function named as readNet from ONNX, and this will take one argument, which is the name of the model. Now the next thing we need are all the classes which our model can detect. So for this, in my project directory there is a file named as coco.txt. It contains all of the 80 labels which the model can detect. You can find this file at the link given in the description. Now what I will do is that I will read this file from my program, and to do this I will write file equals to open, and this function will take two arguments. First one is the name of the file, and then I will give the flag, which is R for read. Then I will write classes equals to file.read, and whatever this file has, we will create a list of it. So I will use split function, and inside it I will write \n. Now let's print it to see if we are getting the list of labels or not. So let's run the code. Now in the console window, we got a list of all the labels. This is what we need. Now we have loaded the model, and we also have the list of all the classes. The next step is to feed our model with the images we are getting from the video. But before that, we need to process them. So what we will do is, we will create a blob of image, or in simple words, we will process it. So in this while loop, here I will write blob equals to cv2.dnn, and inside this there is a function named as blob from image, and this will take some parameters. First one is the image to be processed, and the second parameter is the scale factor, which is going to be 1 divided by 255. What this will actually do is, it will normalize the image pixels. In other words, the pixel range of our image is from 0 to 255 and it will change this range to 0 to 1. The third argument is size, which is going to be 640, 640. And the reason for this is this model was actually trained on the images with the size of 640 pixels. Now the fourth parameter is the mean to perform mean subtraction, but we don't want to perform any mean subtraction, and that's why we will set it to 0 for all the 3 color channels. The next argument is the swipe RB, and we will set it to true. And this is because by default we are getting the image in BGR format, but the model needs the image in RGB format. So this will simply swipe the blue and red channel. The last argument is the crop. We will set it to false because we don't want to perform any cropping. Now after processing the image, we will provide this blob to our YOLOV5 model. So I will write net.setInput and then I will give the blob. And after this we can run the inference. So for this I will write net dot and then I will use forward function. And to store the result we will get from this, we will use a variable, let's say detections. And also here I will write 0 in brackets. Now just for understanding, let's print it to see what we are actually getting in it. Now I will run the code. Let's close it. Now in the console window, we are actually getting the NumPy arrays. Now this time we will print the shape of these arrays. I will run the program again. And now here you can see the shape of the array. It has 25,200 rows and 85 columns. Let me explain this. What actually happens is that every time we give the image to this model, it predicts 25,200 bounding boxes, or you can say detections. Among these, most of the detections have very low confidence and we are going to ignore them. Now the 85 columns shows that for each bounding boxes, we are getting total 85 entries. Let me write it for you. The first two entries, let's say CX and CY, are the center of the bounding box, and then we have width and height, and then we get the confidence value, and the last 80 entries are the class score of all the 80 classes. Now what we will do is that we will find, okay, let me write it here. We will find class IDs, then confidence score, and then we will find the bounding boxes. So what we will do is we will create a list for each of them. Now I need the number of rows the arrays has. So I will write rows equals to, and as we know from here, there are 25,200 rows. So you can write this number here, or otherwise we can write detections dot shape, and then we will give the index which is 0. Then we will find the width and height of our actual image. So here I will write image width, comma, image height equals to img.shape, and for the width the index is 1, and for height index is 0. After this we will find the scale factor for both width and height, which we will need later. So for width I will write x scale equals to image width divided by 640. Now the reason I have divided it by 640 because here I have set the size of 640. In the similar way, I will find the scale factor for height, and this time we will use image height. Okay, now after this we will pick the rows from the arrays one by one, and then from the rows we will extract all the required information. So here I will write for I in range, and inside it I will write rows. And inside this for loop I will pick one row at a time by writing row equals to detections, and then I will give the index, which is I. Now from this row we will extract the confidence score. So we will write confidence equals to row, then I have to give the index. So here if we look at this sequence, the confidence is the fifth entry, so the index will be 4. Now before extracting the remaining information, we will first check if the confidence value for this detection is greater than a certain threshold, let's say 0.5. Only then we are going to consider the detections, otherwise we will ignore it. So for this, I will use an if statement to check if the confidence is greater than 0.5, and if the condition is true, then we will extract the class score for all the 80 classes. So for that we will write classes score equals to, and as I told you before, these are the last 80 entries. So here I will write row, and in the bracket I will write 5 colon. Now the next step is to find which class is detected. So for that I will find the index of the maximum class score, which is also the ID of the class which is detected. So here I will write int equals to np.argmax, and inside it I will give all the classes score. And in this way we will get the index of the maximum class score. Now we will check if the maximum class score is greater than a certain threshold value which we will set by ourselves. So for this I will write if class score, and then I will give the index, which is int. And if it is greater than 0.5, only then we are going to consider this detection. Now if the condition is true, then we will append its class ID in the class IDs list. And then we will add the confidence of this detected class in the confidences list. And then I will add the bounding boxes, but before that we need to find it. So for the bounding boxes, I need the x and y coordinate of the center, which are, let's say, cx and cy. Then we need width and height. And to get them, let's see the sequence. These are actually the first 4 entries. So here I will write row, and the index is from 0 to 4. Now from this we will find the top left corner of the bounding box. So I will write x1 equals to cx, and then we will subtract half of the width. Now this point is actually for the image having the size of 640. To get it for our actual image size, we will multiply it by the scale factor. And then we will convert it into integer. In the similar way, I will find the y coordinate. Now also the width and height we have are for the image having the size of 640. So I will also multiply them with their corresponding scale factor. Now after this we are going to write box equals to, and then we will create an array, and inside it we will add x1, y1, width and height. And then we will append this bounding box in the boxes list. Now we have all the information. The next step is to put them on the image before displaying it. So I will use a for loop. And then first I will take the coordinates of the bounding box. So here I will write x1, y1, w, h equals to boxes, and then I will give the index, which is I. After this we will find label. So for this we will write label equals to, and the labels are in classes list, and then I will give the class ID. So for this I will write class IDs, and then I will give the index, which is I. After this we need confidence. So we will write conf equals to confidences, and the index is I. And after this I will write text equals to label, and I will concatenate it with confidence. Now to draw the bounding box, I will use the rectangle function of OpenCV, and this will take the image, then top left coordinate, and then the bottom right coordinates, and then I will define the color of the rectangle as blue. Then I will give the thickness. Now to put the text, we will use putText function, and inside it we will give the image, then the text, and then the location where we want to put the text. Then I will set the font, then the font scale, then the color of the text, and then I will give the thickness. Now I think everything is fine and the code should work. So let's run it and see. Okay, I need to do one more thing. I will round off the confidence value up to 2 decimal places. Now I will run the code again. Okay, this is the result we are getting. Now if you notice, then you will find that for every detection we are getting multiple bounding boxes. So in order to solve this problem, we will use a technique known as non-maximum suppression. I'm not going in too much detail of how does it work. We will see that in future videos, but for now what we need to know is that it will remove the extra bounding boxes. So for this, here I will write indices equals to cv2.dnn, and inside this module we have a function called NMS boxes. Now this will take 4 arguments. First one is all the bounding boxes. Then it will take the confidence. And then third argument is the confidence threshold. We will set it to 0.5. And then it will take NMS threshold. We will also set it to 0.5 for now. And here I will replace it by indices. Now I hope this will work. So let's try it. Okay, now you can see that the extra bounding boxes has been removed. So this is how we can use YOLOV5 with OpenCV DNN module. Now I believe the code we wrote is a bit difficult. So in case if you did not understand something, then you can ask me in the comment section. That's all for now. Thanks for watching.